Today's lecture is chapter 8, shoring systems. We have studied before chapter 7, which was speaking about retaining walls and lateral earth pressure. So it was mainly discussing something called retaining walls. Now we have something called shoring system. What is the difference between shoring systems and retaining walls? They both deals with lateral earth pressure. Let's just see, this is a photo of a retaining wall. Here, this is photos of different types of retaining walls. But what is a shoring system? Actually, a shoring system is something, we can say that a shoring system is a temporary system. It is a retaining wall, but it is temporary. This is the first thing. The second thing, it can be constructed from ground surface. This is very important, because if I want to construct a retaining wall like this, or like this, or maybe any other, here, if I want to construct this retaining wall, how can I construct, this one in this photo, how can I construct this wall to retain the soil behind it? How am I going to keep the soil in place while constructing the wall? Have you ever thought of this? This retaining wall, the function of this retaining wall is to retain the soil behind it. But the soil is now there. How will it stand till I finish my retaining wall? In this case, I will need a shoring system. So a shoring system is a temporary system that I install or construct to give me a space to work, to finish whatever building I want to construct, or whatever retaining wall I want to construct. Then I can remove this shoring system and leave my retaining wall, or leave my basement, or leave my whatever building that I needed below ground. So this is exactly what is here. This is a building, and this is my new site. I want to excavate here to reach this bottom layer. If I excavate here, what will happen? The small portion of soil here will collapse, and my building may collapse, because it's not this only. You may find that soil like this. Take from here an angle 1 to 1. Everything, or 1 to 2, and everything on top will fall. So I need to construct here. Maybe in your design you have a retaining wall here. Maybe. How to construct this retaining wall? To construct this retaining wall, I need to retain the soil before constructing the retaining wall. So I will need to go to the surface of the ground here and construct a permanent shoring system to retain the existing soil and retain the buildings and retain everything behind it till I construct my permanent retaining wall, and then once I finish, I can remove my temporary system. So this is exactly the difference between both, because sometimes people may mix both together. Sometimes, for quick response, you may use the word shoring for a retaining wall, or you use the word retaining wall for a shoring system. But if I tell you in one word that I have a shoring system and a retaining wall, it means that I mean the specific meaning of each term. Shoring temporary from ground surface. It does not need any other systems to be constructed. Retaining wall, it is permanent. It may, 95% it will need something. This something may be a shoring system, may be open excavation, anything. Suppose you are doing this excavation in the middle of the desert. So I don't need a shoring system. I need to excavate, but I don't have anything around me. So what will happen is that I will excavate, and anything that will fall from this side, it will fall inside, and I will remove it. I don't, it's not a big deal for me. Later, when I finish constructing my building, I will just fill or backfill this portion again. But because I have structure, then I need a shoring system. So this is very, very important. You may find engineers who don't know the difference between shoring and retaining wall. So these are just what we have just said. This is the depth of the excavation. Here is the soil want to fall. So I will put an excavation side support, which is a shoring system. Here, the function of this is to retain everything behind it. These are photos to see what we have just said. This is my site. Here is a building. It's an existing building. If I excavate without putting this shoring system, this building will fall inside. The same here. This is very, very clear. It's a very deep excavation in the middle of the city. So you have buildings, streets, everything around it. In case of doing excavating this depth without a shoring system, all these buildings will collapse inside your excavation. The same here is, this is for a street, and the building here. This is a shoring system here and all around here. This shoring system retains the building. This shoring system retains the street. This shoring retains the street, and so on, the streets from the three sides. I may use this shoring system to work inside water, because it's the same. Similar to retaining streets and building, I may retain water. Let's see some photos. I want to work here. This was previously part of the sea. This part was part of the sea. But I want to work here. How can I work here? I put this shoring system all around. I de-water these pumps here. Take the water from inside to outside. Water cannot come inside with the same quantity that I'm taking outside. So here will be the dry side. I can work in the dry and finish everything. And once I finish, I will just remove this system and water will come back again. But after finishing my construction, whatever is, maybe here I'm putting the foundation of a bridge. Similar, same photo. This is very, very clear. This is the mainstream. And you need here to do something inside. Just put this shoring system all around, de-water or take the water from inside, then you can work in the dry side. Sometimes the shoring system is included inside the permanent structure. It is a shoring system. It is meant to be a shoring system. But later, when we finish, we decide that we want to keep it part of the structure, or we do this at the early stage of the design. Here, sure, I will remove this system all around, but in some cases, I may construct a shoring system, but I will construct it from a material that can live long time without problems. I cannot usually I do not use steel to be permanent below water because it will rust with time. So what happens is that in some cases, something like this, it is more or less similar to a deck, a harbor, mina. So in this harbor, they want to construct a wall. So they have done this. This may be, by the way, steel, but in this case, it will require additional precaution. What is this additional precaution? Something called cathodic protection. This is something related to mechanical engineer. They design something called a cathodic protection. What is the function of this cathodic protection? It prevents steel from rusting, because rusting of steel is actually a chemical process that changes to be an electric process. Electrons transferring from one side to the other and so on. So if I manage to put opposite charges on the steel, then it will not rust. So this is what will happen. They will connect this to a battery, and this, of course, powerful battery, and this battery has opposite charges to what will cause rust. So in this case, rust will not happen, but it is expensive. That's why in many cases, I will show you a picture for a different case. Usually we do it from concrete, because concrete can resist water without the need for any cathodic protection. Yes, you can read this text. Here, this is what we said in the introduction. What is the difference between why do we use shoring system and not retaining wall? If I want to use a shoring system to construct, let's see, this is page 50. If I go to this, why don't I construct, instead of constructing here a shoring system, why not a retaining wall? The answer is what I've said in the beginning, because to construct the retaining wall, you need a shoring system. You cannot just take the retaining wall and you put it in a place. You cannot do this. You need to put a shoring system. So that's why we will need to construct any of these. Let's check what is the types of the retaining wall that we have studied before. This is the gravity type of the retaining wall. This is another type, which is the cantilever type of the retaining wall. This is the counterfort or the retaining walls. All of these you cannot construct it next to the soil. But a shoring system, you can construct it inside the soil. I go to the ground surface, just inject or push my shoring system inside the soil, and once I push it, it is in place. So I don't need any excavation, any prior excavation. But to construct this or this or this, you can see here in the photo, this is the soil. They needed to remove the soil first and then construct these walls, and then after constructing the wall, you see here the hand of a person. So after finishing, they are going to backfill here, and that's all. So they needed to conduct a prior excavation. The shoring prevents you from doing any prior excavation. If I just remove this retaining wall and put a shoring system that can be implemented for a long time, then in this case it will start acting as a shoring system, and once you finish the target of shoring system, you use it as a permanent retaining wall. We will see in a photo something like this. So let's first go, what are the types? We are saying that we can just dig or push a shoring system. What are these shoring systems? The first type of shoring system is called steel sheet pile wall. This, remember this name because you are going to hear it a lot. Sheet pile wall. Sheet pile wall in Arabic we call it الستائر الحديدية. Both expressions are used a lot. When you see it, I'll just these are the details, but I will just go to this. These are the sheet pile wall. What is the sheet pile wall? The sheet pile wall are just some steel sections, pre-constructed, prefabricated sections. You just take from this point to this point, this is one section, and from this point to this point, this is another section, and so on. So what will happen is that this is a section, and this is another section. This is different types with different shapes and different dimensions. You just connect them together and push them inside the soil. But let's see how we do this. This big machine, it takes this one is one like this. This is the cross section of this. So this section is taken by this machine, and this machine start pushing. It's very big and powerful machine. It start pushing this this section into the ground, and once it finishes and it reaches the maximum depth that it can reach, they move to the next one. So they finish this one, they go to this one, and then this one, and then this one, and this, and this, and this, till they finish a curtain. It will be a wall-like system. So it is a wall that is constructed, made of small portions. This, you look at this is one portion. Of course, it is connected, continued, and this is another one, this is another one, this is another one, and it will continue. So what will happen if I finish this and this and this and this? I will have a wall pushed inside the ground. So this will be the shape that I will get at the end. So when I finish this wall and this wall in the other, you see here at the bottom, this is a continuation. It is continuing, pushing. Once I finish, I can easily excavate inside. The soil will be here outside. It will be at the ground surface, but here I may reach 10 meters, 20 meters below ground. So I can excavate inside. This is a presentation. This is the machine. These are the pieces of the curtain walls, and the machine just pushes. Yani it started with this one, then this one, this, and now it is pushing the last one, and it will continue pushing them all together. Once I finish, I bring this machine to excavate till I reach the level I need. Here was the ground level, and I want to reach this level. So I managed by putting this sheet pile wall to excavate inside without any problem. But once I finish everything, what I'm going to do with this steel? If I leave it in the ground, it will be a waste of money, it will rust, it will cause problems. I remove it again and use it in another site. So doing it made of steel is a benefit because I can use it in many projects, not just one project, and it is just pieces. I can design it anything I want, because if you look at here, this one, if I put this one like this and I put the other in the opposite direction, then I will get a thin wall. But if I want a wall that is wider in width, I put this one in this direction. So now the width of the wall is from this point to this point. So I get bigger dimensions. So I can use it in. Of course, you will face a problem. What is this problem here? Is that sometimes you cannot push your steel sheet pile wall to the required depth. Suppose that after pushing it for a while, it's stuck because there is a piece of rock that is below. Then you will see this shape. What is this shape? That not all of the steel pieces have reached the full depth, but I don't care. It will still carry the load behind it. I don't need to cut this extra steel. I will just work inside. But usually we don't use this steel unless we are sure that the soil is good and it will not. Nothing will prevent the passage of the steel sheet pile wall. I cannot use this system in rock. I cannot use it in rock fragments. I cannot use it in boulders, but I can use it in sand, in clay, in silty sand, silty clay. All of these are good for that. Here is another photo. This is the pieces of the sheet pile wall. This is the machine, and the machine is pushing these steel portions to go inside the soil. So once I finish, then I will have this wall. I can dig any side of the wall. I can dig on the left side or on the right side. It depends. Usually we don't do walls. We do closed areas so that we can excavate inside. So it will not be just one side. It will be four-sided shape so that I can excavate inside. So this was just the beginning of the installation of the wall, and they will continue in different directions. Here we are working inside water. Here you can see exactly what I've just said. You see these portions? This shape is not a C, it's a Z shape. It starts from this point and ends at this point. It is Z shape. So if you connect a Z shape to another Z shape, you can take double the height or maybe the same height. It depends on the way you are connecting. Here you are using just one single height, but if you connect this piece in the opposite direction, the height will be doubled, and so on. Here, inside water, and if you look inside, you see here, this small thing, it's a person. Is somebody inside here, and this small thing also is another person. Here is another person, and here is water. So it's just inside the water, and they are reaching very big depths below ground. Another example, this is a very famous picture. Inside the sea, and here this is an equipment. So at least this is, you can say that it is about 20 meters below the sea. Another example. You have lots of examples for that. So all of this are sheet pile wall. What is the problem of sheet pile wall? Expensive, of course, because it's made of steel. It may rust with time. It will cause a lot of noise during construction because you are pushing steel pieces inside the ground, so it's making noise. You may need to hammer it to go inside. It will affect the neighbors and the neighboring facilities. There is some difficulty in implementing it in hard soil. So these are the disadvantages of the steel sheet pile wall, but of course it is very, very good and very efficient in many cases. There is another type called soldier pile and lagging. What is soldier pile and lagging? This is a description of it. Let's see first a photo of it. You see these steel sections? What I need to do is that I go from the ground surface. Here, I'm standing on the ground surface. I drill a hole, like a borehole. And once I finish drilling, of course, drilling a hole in the ground, I can penetrate any layer. If I have rock, I can penetrate the rock. If I have anything, I can penetrate. It depends on your machine. So by this, I can be sure that I will reach the depth I need. So I drill here till I reach the depth I need. And then when I finish this, I go to this, and then I go to this, and I go to this. So I finish the whole site all around with holes. And once I finish the hole, I insert a steel section, maybe I section. You know the I, instead of C or Z, there is something called I section. So I put here an I section, an I section, and I section. And I can pour concrete at the bottom so that the I section will be fixed in place. So not just a loose I section. No, I put suppose you are drilling 10 meters, maybe 3 meters from the bottom you can pour concrete. So now I have I sections all around my site. So what I'm going to do, I'm going to go to the site and start excavating. I will just excavate a small depth. I can do this with soil that is medium or a little bit. It can carry, I need soil that if I excavate, say 50 centimeters, it does not fall. So what will happen? When I excavate the first layer here, I put something called wooden lagging. I take pieces of wood and I insert it between the I sections. I have I section here and I section here. So I bring a wooden lagging, a piece of wood that reaches from the first I section to the second I section. So I put the piece of wood, say it is 50 centimeter depth, and I put it inside. And then I go to the next one and next one. So now I have I sections with just 50 centimeter of wooden lagging all around. And then I excavate again. Maybe I take another 50 centimeters. So what will happen to this wooden lagging that I installed at the top? It will fall down. So it will fall down and the remaining will be 50 centimeters. I put another wooden lagging and excavate and put another and excavate and put another till I reach the depth I need. So I can do this. I cannot do this with very soft soil. I cannot do this with sand, because if I do this with sand, it will just jump. It should be silty sand, clay sand, so that it can stand in place for 20 centimeters, 30 centimeters, anything that I can put the lagging. And even if the topsoil fails, what's the problem? Suppose that you have an excavation and once you put, I will take this photo, let's see. Suppose while drilling here for the first 50 centimeters, the soil collapsed. Okay, it will collapse once, and I will remove but it will collapse for 50 centimeters or 30 or 20. That's all. It will not collapse for the full excavation depth. So, and each time I put the wooden lagging, the collapse will happen for once at the beginning, and then there is no other soil to collapse. So I can, even with some soft soil, I can proceed using this. But it is better to have soil that can stay in place for a fixed length. This is a photo. This gives you an indication of the wooden lagging. This gives you an indication of the wooden lagging connected to the eye sections, the steel eye sections. You see this this site. This is wooden lagging all around. It is fixed maybe in a different way, but you can consider it the same. Here the same. Here I needed to go very big depth. And this, you see, this orange thing, it's a person, and this another person. So this distance is very, very high. Sometimes we need, this eye section will not stay in place. I need to fix it in place. So what will happen is that they put these anchors. So it is soldier piles. By the way, we call these soldier piles. Why soldier? Because they guide the way for the wall. So these soldier piles with wooden lagging, I added to them a level of anchors. So instead of just drilling maybe 10 meters, I can drill 20 meters with this system, 30 meters, maybe add another level. When I go deeper, I put another level here of anchors, and so on till I reach a very great depth below ground. This is the same. This is the eye section. This is the wooden lagging. Here at this location, this is the inclined anchors. Of course, if you put the anchors, you need to put a beam here. So this is the beam, and these are the anchors that I was speaking about. These anchors are drilled, inclined inside the soil to keep this eye sections and wooden lagging in place. Because if you have an anchor, it will prevent the wall from tilting or from falling to inside. The same here. This is all around. This is anchors, a level of anchors here, and people are working inside. The same, also the same. Just lots of photos so that you can understand what is the disadvantage. It is necessary to ensure that the soil will not collapse during construction. If you look at this photo, just take this photo here. You see here the soil was very strong to the extent that we did not need to push the wooden lagging below, because it will stay in place. So the wooden lagging was used from this height to this height because there was soil, but maybe at this location it was rock. I don't need wooden lagging, so I just they did not push the wooden lagging further below. So suppose that this was not this was sand. It means collapse, because sand will just flow here and anything on top will collapse. So what is the problem of this system? Where it is disadvantage of the system? Yes, disadvantage. It is necessary to ensure that the soil will not collapse. This is important. Soil should not collapse. That's why I said you need to use it with a medium type of soil, not a loose type of soil. Not suitable for weak, non-cohesive soils like sand, loose sand. You cannot use it. Not suitable in the presence of groundwater. Of course, it will not prevent groundwater. In sheet pile wall, it prevents groundwater because steel prevents water from passing. But here, the wood, water will pass in between. Here, during construction, and this is the soldier steel I-beams, and this is the wood, and they are trying to get the wood to the bottom as much as possible till they support everything that is loose. Anything that is not loose and can rock-like material, then it can be kept in place without any wooden lagging. And so on. These are different photos. It is usual to see this, that you have wooden lagging on top and then you don't have wooden lagging below. Why you don't have wooden lagging below? For two reasons. The first reason is that the soil is good. The second reason, that something I said before, I don't just put the steel I-beams alone. I pour concrete to fix it. So starting from this depth, maybe you have concrete. You cannot just ask the wooden lagging to go below. It is already, you cast concrete inside. So you can do, so that's why what we are going to do is that this is soil, this is rock. I drill holes here in the soil and penetrate the rock, and then put the steel section, and then pour concrete till the rock level, and then leave the wooden lagging alone in the soil. So when I drill in the soil, I start putting the wooden lagging one by one till it reaches the top of the or the start of the rock, or it may penetrate a little bit in the rock. Then I stop pushing these wooden lagging below, because I cannot push them further. The other thing is RC piles. This is very, very important, and we use it in Egypt a lot. Here, say we use it 50-50. The sheet pile wall 25 to 75, but here we use it 100% or 90%. So, using RC piles in any site is the normal. If you go to any site and you want to do a shoring system, 90% it will be RC piles. So what they do, they construct these piles next to each other. I will show you here a photo for the distance, but let's see first the shape. You see here, these are all piles. Of course, this is very, very good construction. You see, piles are very accurate, and they are very, usually if you look at the piles after construction, you find deviation and angles go, piles inclined with 5 degrees, 4 degrees, and so on. This is bad construction. But here, this is a very good type of construction. Piles are very close to each other, and they could excavate inside very easily. You see this shape, very, very good. And here, these are the piles, and they continued on top of the soil with a fence. Just something for decoration. It's not very important, but it means that it can be incorporated inside my building, and I can use it as if I'm putting here a foundation for my fence, and I can continue. It is very, very good in many ways. Another picture showing the shape of the RC piles used. Here, you see here, this is an RC pile, this is an RC pile, this is an RC pile, and so on. So this is a shoring system. I can excavate inside, and outside I can leave the height as it is. And once I finish, I may incorporate this shoring system to be a retaining wall. How can this happen? They just covered the face of the shoring system with these reinforcement, and they are going to use concrete, shotcrete. They are going to cover the face of these piles instead of having bubbles of piles. It will be finally a smooth retaining wall. as if it was a retaining wall that was constructed. So this is what I meant by a shoring system being later incorporated in my system to be a permanent wall. So at the beginning, these piles were a shoring system. They were constructed from the ground surface. They were supposed to be temporary, but once I finished, and because I need this area to be exposed, I'm not going to backfill here, so they just cover the face here with any type of cladding. Here it is concrete cladding, just covering the surface with a concrete wall. So now it is a permanent retaining wall. Let's go to what are the types of RC piles. We have really three types of RC piles. If I'm drilling in very cohesive, not cohesive in the I mean clay, but I mean the soil is stiff and can carry, I can drill vertically without big problems. So if I construct this pile and next to it another pile with a gap inside, in between, and another pile with a gap, and so on, something like this. This is the machine that is drilling, and I leave a portion and then drill another, and leave a portion and drill another, and then once I finish, I put the cage of steel and then pour the concrete. So when I finish, I will find that I have piles with gaps in between. Maybe this shape will let you understand what I mean. This is a pile, this is a pile, and this is a gap. Soil here is not falling because soil can carry itself in between these piles. It is not a big deal, because if you look at closely to this soil, you will find it is a little bit clayey, so it can stand as it is. So this type, of course, why I'm leaving this gap? To reduce the amount of money that I'm paying. Instead of using 100 piles, I may use 70. So I just added spaces that can carry itself without the use of piles. So I'm reducing my expenses. So this type, we call it adjacent piles. Adjacent in the sense that they are near to each other, but they are not touching, they are just near. And there is a gap between these piles. So this is the drawing. This is the first pile, and this is the pile diameter, and there is a gap. This gap may be 10 centimeters, 15 centimeters, depending on the type of soil. Why not 20, 30? You can go more if the soil can carry itself without failure. So this is the first type, which is adjacent. What is the advantage? Of course, reducing number of piles, so reducing money. But what is the disadvantage? The disadvantage is that it is only suitable in good soil. I cannot use it with water table, because water, of course, water, in a gap of 20 centimeters or 15 or 5 centimeters, water will pass. So I cannot use it with water. This is the main thing. So this is the first type. The other type is called tangent pile. Tangent pile is, my piles are just touching each other. Of course, it needs a very, very good control over the drilling operation, because if I'm doing two piles next to each other and they are supposed to be touching, and one of them deviated outside with 1 degree and the other deviated inside with 1 degree, so finally they will end up with a gap in between, maybe 20 centimeters. So it needs very high control in the construction to construct pile just like this. They are just touching each other. Of course, this is very good, but they can be used for loose soil. Because soil now cannot pass in, if there is a gap of touching, the soil cannot pass. But if I have water, it will pass. So now I am rectifying the previous one to be able to use it for loose soil, but I cannot use it still for water. So this is the second one, which is called tangent piles. Here, the same that we have just said. Of course, we are dealing between the number of piles, which is related to cost, water passing or not, soil passing or not. These are the three items that I have to check every time. The third type is called secant piles. Of course, now you can understand what I mean. Secant piles means that I need my piles to be penetrating each other. I don't want any gap between the two piles. How can I do this? I do this by doing, I need this drawing. These are called bentonite piles. They are helping piles. They are not the main piles, but they are used to prevent water. You remember my problem here was that in tangent pile I have a gap. Not a gap, but I have, they are touching. So any minor construction fault will result in water passing. So I need to put a plug here to prevent water from passing. This is exactly what I've done here. To do this, I do it in two stages. The first stage, I drill these piles. You see these dark piles? They are not made of, they are not reinforced. I just drill and put cement with bentonite and so on. So it is just a plug. So I have this pile, and I have this pile, and I have another one, and another one, and so on. And there is a gap between this first pile and this second pile. And then I bring my machine, drill in between. In this case, when I drill in between, I am touching this and touching this. This is a plug, and this is a plug. Water cannot pass here, and water cannot pass here. And then I put my reinforced concrete pile. When I put my reinforced concrete pile here, this will be a very strong, of course, this is just a plug. It is not strong. It cannot support the wall. The wall is supported on these reinforced concrete piles. But these are just plugs to prevent water here from passing to the other side. So you will end up having these reinforced concrete piles. These are the main stiffeners for the wall. These are the things that carry the wall. And having these plugs or the bentonite piles or the secondary piles, whatever the name they call it. So now I end up, this is a photo. This is the concrete pile, the reinforced concrete pile, and this part of the pile is the remaining of the secondary pile that I have drilled at the beginning. So now, if I have water inside, how can water pass? It cannot pass, because it cannot pass through the concrete pile, it cannot pass through the plug, and it cannot pass all around. So here, this is a watertight section. So secant pile, what is the advantages? Suitable for excavating below ground table. The disadvantages, of course, the number and the price has increased. So this is a presentation. This is the first I construct this plastic pile. So it is plastic pile, bentonite pile, secondary pile, whatever you call it, plug, anything. This is what do we mean by this pile. So this pile is the plug that I'm using to prevent water. I constructed first, and once I constructed, I drill inside the soil and inside it and construct my new pile, a new reinforced concrete pile. So this is the final shape. So now this is very good, but it has a limit. It is just a pile. If I need to construct something using this that reaches 30 meters below ground, maybe this is not enough. So to reach higher depths, and of course this needs some kind of lining all of the pile to be in one side, and later if I want to incorporate this to be a permanent retaining wall, then I will need, similar to the previous case, that I will have to put cladding from this side and to have a smooth wall instead of having bulbs of piles. There is something called a diaphragm wall. Maybe you have heard a little bit about this diaphragm wall. What is a diaphragm wall? You just go to the shape of it. Diaphragm wall is something more elaborate. Instead of drilling piles, this is a machine. I don't know if I have a shape. No, I don't have the shape of the machine, but it is here in this place. This machine have cutting edges below. You insert this machine on top of the ground, and it goes down, and while going down, it creates a hole, but this hole will be a rectangle type of hole. So it will create a rectangle space. So I will do this one, and then this one, and then this one, and then this one. So I'm just drilling, and then once I finish drilling, I put a cage of steel, and this time the cage of steel will not be circular. It will be a wall, a cage of a wall, and then I cast concrete. So it will be a reinforced concrete wall inside the ground. Once I finish, I bring the machine. What is good about this machine? It drills from here, and it also can cut from the sides. Why it is important? Because once I finish this one and this one and this one, I bring the machine and I put it in between these two walls. So what will happen? It will drill and it will grind the surface of the two walls next to it. So it will encroach in the other two walls. So it will create a gap in the soil and touch the wall to the left and touch the wall to the right and drill inside them also. So when I construct the wall in between, it will be connected to the previous wall and the next wall. So finally, when I finish, I will find that I just did not have rectangular sections. I had a full wall with the width of the rectangle section, because it's just pieces of wall next to each other. Of course, I do it one and I leave one and I leave one, and then construct the ones in between. I will end up having the full length of the wall as if it is one unit connected to each other. There is here something just for just to know how we calculate this. An example: suppose you have an area 25 meter and 40 meter, and I need to calculate the number of RC piles that I will need to construct a system. He has given me, you have adjacent piles, tangent piles, and secant piles, and he gave me the dimension. The pile diameter is 50 and the gap here is 0.1 meter, and so on. He gave me all the dimensions. He just tell me, count the number of piles that you need. So in the first one, you are just going to count the number of piles. In the second one, you are just also going to count the number of piles, but it will be more because you don't have gaps. Here you are going to count the number of plastic piles and then count the number of reinforced concrete piles. So this is this is what is the perimeter? The perimeter is 25 plus 25 plus 40 plus 40. This is 10. This is 100. It should be one. Of course, it's not 10 meters. 80 and 50. It is. Oh yes, 130. So this is there was supposed to be a 3 here. So just let me do this. Okay. So now I have here is the perimeter. The required length it's 130. So I will take this 130. Of course, obviously it is the problem. The problem is in many. All of this should be changed. Anyway, I will just divide them by the. I will have to check. Maybe this unit is just the unit is not the correct one. But anyway, you just calculate the perimeter. And you see what is the space, the length of each unit. If I am using this type, then one unit, say it is center line of the pile to center line of the plastic pile. What is this distance? I divide the perimeter by this distance, so it will give me a number. This number will be the number of plastic pile and RC piles, and so on. Here, in the other one, if they are tangent piles, I will just take the perimeter of the pile and then divide the whole perimeter with the diameter of the pile with the diameter of the pile, and so on. Just for understanding what we are doing. So in the 3 cases, I will calculate the number of pile for adjacent and tangent pile and for secant piles as well. That's all for this lecture. I think we now know the difference between shoring and RC and retaining walls. Sometimes, as I said, people may misuse the 2 terms, but if in one sentence I say I'm using a shoring and an RC and a wall, then I mean a shoring and I mean an RC, I mean a wall. That's all, and see you next time. Thank you.